Okay, this is going to be the last example that we do for this particular section. Reading that third problem, again, go and highlight all the information that you're given to determine which formula you're going to use. So I have 5.36 liters of nitrogen gas are at negative 25 degrees Celsius and 733 millimeters of mercury. What would the volume be? That's what's being asked at 128 degrees Celsius and 1.5 atm. Again, going to the side and listing everything that we have. I have a volume of 5.36 liters. I have a temperature of a negative 25 degrees Celsius, knowing that I can't just leave it like that, that I have to have 273 added to it. This is actually equal to 248 K. I have a pressure of 733 mmHg, millimeters of mercury. They're asking me for my volume. I have another temperature of 128 C. Again, I have to add 273 to that, which gives me 401 Kelvin. And I have a second pressure of 1.5 atm. Now, another reason that I mentioned in class that I want you to list all of these in this particular way is because it allows you to see that all of your units match up. I have volume, and now I can see I have a volume 1. They're asking me for volume 2. I have a temperature 1 and a temperature 2. Both of these are in Kelvin. And I have a pressure 1 and a pressure 2. But what do we notice about our pressures? They are in different units. So therefore, we need to convert one of these. Now, it doesn't matter whether you convert millimeters of mercury to ATM or whether you convert ATM to millimeters of mercury. It will give you the exact same thing. But what you have to know is the conversion factor that 1 ATM. Let me change that color. Really don't like that too much. Let's use red. That 1 ATM, that's not red, is it? That's equal to 760 mmHg. Now, this was given in class, so it should be in your notes. I am not giving this to you on the test. This is something that's very, very easy to memorize. So I have 1 ATM is equal to 760 mmHg. I think I'm going to convert my mmHg to ATM. I think that's what I like to do. So I have 733 mmHg. Conversion. I know I want my mmHg on the bottom, and I'm trying to convert to ATM on the top. Look at those numbers. I have 1 and 760. So then when I do the math, I actually get that 733 is the same as 0.96 ATM. Okay, so now I can go ahead and plug everything into my formula. Now the question is, what formula do I use? If you've been studying your formulas, you know that this is the combined gas law. So we have PV over T equals PV over T. I'm looking for V2, so that means everything else needs to come to this other side. So I have T2 P1 V1 over T1 P2 equals V. Plug all of that in. V2 is equal to T2, which is 401 K. P1, which is now 0.96 ATM. V1, which is equal to 5.36 liters, all over T1, which is 248 K, times P2, which is 1.5 ATM. And when we put everything in our calculator, and we know we're putting our numerator in parentheses, denominator in parentheses as well, 5.5 liters is going to be our answer, because everything cancels out except for liters. And there you go. Good job.